define, es la incógnita constante, la que ha guiado nuestros pasos en la búsqueda incansable de la excelencia. Durante 65 años de incontables logros en el desarrollo técnico y administrativo de la industria que mueve al mundo, contamos con los primeros posgrados de ingeniería de petróleos del país, pero ser los primeros no basta. Cada día trabajamos para ser los mejores. El tiempo nos ha dado la experiencia, pero marcar la historia define la grandeza. Únete y mueve al mundo. UIS, Maestros de la Industria Petrolera.
Hello and welcome everybody. My name is Katarina Yerid. I'm currently the president of the Society of Petrophysicists and Well Log Analysts. I hope to bring to you more understanding of what our society is all about. First and foremost, it's knowledge sharing. Petrophysics has been around for a while, but it hasn't had the title of petrophysics for all too long. What we're here to do as a non-profit society is to provide the knowledge sharing that no other industry or no other entity can provide. Universities are including formation evaluation, log analysis, and petrophysics as subcategories. But as a whole, to make the picture complete, our society is there to provide knowledge sharing as well as networking opportunities for better understanding of what the subsurface measurements are all about, as well as combining multidisciplinary information like geology, reservoir engineering into one big complete picture. No matter where you're gonna be heading, if it is renewable energies or oil and gas energy, you will have to deal with subsurface. Petrophysics, formation evaluation, log analysis, no matter what you want to call it, is always going to be part of the complete understanding of the matrix system as well as the fluid system in the subsurface. Therefore, I encourage you to join our society early and be part of our network as well as an active member. And we hope that with your help, we can contribute to overcome the energy transition smoothly, as well as being able to contribute to a further sustainable and renewable energy solution to the world. Please join me in this endeavor. I thank you very much, and I hope to see you all very soon, either virtually or hopefully in person. Bye for now. Hello and welcome everyone.
Olá, amigos de Colômbia. Hagamos miembros de SPULA, uma oportunidade única de difusão e aprendizagem da ciência da petrofísica. Contato com petrofísicos da mais diferente especialidade e, o mais importante, trabalhar em equipo. Ven e únete a esta grande família petrofísica.
Hello, my name is Francisca Gunawan, VP of Education of SPWLA. SPWLA is a non-profit organization that focuses on the formation evaluations and petrophysics. Here we will learn and grow together in amazing community.
Good afternoon, everyone. My name is Eric Quesada, Director of the SPWLA UIS Communications Committee, and I will be moderating the following session titled Petrophysics in Mature Fields in Brazil, an event organized by the SPWLA UIS and SPWLA USCO student chapters of Colombia. In this day, we will be accompanied by the speaker, Bruno Mencio, who is a geologist from the Federal University of Rio de Janeiro, and graduated with honors with a master's degree in geology from the Fluminense University in Brazil. senior petrophysicist with a background in geological operations, meeting the demands of the exploration and development sectors. Complete profile with ability to move through the various applications within the formation evaluation area. Bruno has experience in carbonate, siliciclastic, and unconventional reservoirs. His active participation in the project of acidizing tight sandstones reservoirs extends out, responsible for the introduction of the resisted imaging tool in Brazil. He is currently the Regional Director of Latin America and member of the Technical Committee of the Society of Petrophysicists and Well-Loved Analysts, and has worked in oil companies such as Halliburton, Dataset, Geological Survey for Brazil, BLP Consulting, and INIBA. Before starting, there will be a time at the end of the presentation to ask questions, where you can turn on your microphones or write them in the chat. Then we give you a warm welcome, Director Bruno. Now you have the floor.
So good afternoon and good night for everyone. It is a pleasure for me to help you and contribute in this web meeting organized by SPWA UIS Student Chapter. So thanks, Eric, for the presentation. And this is the title of my presentation, Matter Field Petrophysics. And as Eric said before, I'm SPWA Latin America Regional Director, and actually I'm acting as an independent consultant. So we have here one agenda of my presentation. I will start with an introduction. I will show you the necessary data set, some applications, and conclusions. Introduction. So the first thing that I would like to show you is this question: why matter fields? So 70% amount of worldwide oil and gas production came from matter fields. So even in nowadays, they are the biggest reservoir that's still producing nowadays. And why Brazil? So Brazil is selling matter fields under its ongoing investment program. It includes assets on offshore and onshore. And there are many small size and mid-size companies that are investing in these assets. So independent oil companies are planning sizable investments to revitalize operations in matter fields. So what I will show you in this presentation can be applied for any conventional matter field in the world. But my motivation was Brazil, because I live in Brazil, and I'm seeing actually what is happening, the growing of new companies and selling new old matter assets from Petrobras. So thinking in petrophysics of matter fields, we have two topics that have relevant importance. The first one is reservoir monitoring. We need to understand what's happening with the production in terms of fluids, in terms of pressure, in terms of temperature. So it is really important to monitor what's happening in the reservoir, because it is something that will be very important for field management. And when I'm talking about field management, I talk about some actions that the operator can do, for example, to increase the production. We can inject water in the reservoir or inject gas, for example, and we can use technologies as enhance the oil recovery or increase the oil recovery. And of course, we need a very good knowing of the petrophysics of the reservoir to implement these technologies. So these are the first two things that I would like to mention for you that are really important for petrophysics of mature fields. So thinking specifically in petrophysics, there are three topics that are really important to understand in the mature fields. The first one is the fluids. We need to know where are the fluids, what is happening with the fluids with the time of production, if we have some movement in the water oil water contact, or what's happening with the water saturation. With the time, the water saturation can increase with the production. We need to understand the temperature and pressure that can change the physical state of these fluids. Another topic that is really important is the connectivity, because some reservoirs have some geological layers that contains hydrocarbons, but sometimes these layers are not connected. And for example, we can drain oil from one zone, but there is another sand that it is in another zone that was not drained, and the sand can be drained for increase the production of a field. This is one example of the importance of the geological connectivity of layers. And of course, the main thing here is to understand the production. When we are talking about mature field, this is the most important thing, is we need to understand how much one zone of the reservoir will produce, what is the best zone to produce, what interventions we can do to improve the production, the actual production of one field. So these are the three, I can say, the three most important things for petrophysics in mature fields. And of course, we can apply these concepts for any mature field in the world. So I'll talk a little bit about the data set. This is one, we can see here, three tables. These are the most important data sets that we will need to work with mature fields in terms of petrophysics. The first one is core. We need to have a routine core analysis, spatial core analysis, sedimentology, stratigraphy, and facies. So we need to have a very good model of hydrocarbons in place, and for this we need to have a good calibration between core and log data. So routine core analysis are very important. We need to understand the capillary pressure, the relative permeability, petrophysical properties of our reservoir. And we can do some integrated reservoir studies. For example, we can estimate flow units utilizing permeability and porosity from routine core analysis. And sedimentology and stratigraphy are important because we can understand the lithology. We can predict the best facies based in seismic, for example. And we can understand the positional environment and the facies, because the facies, we can use this information to populate a static model with well logs. So this is a very important information for the mature fields. We need, of course, open hole logs, conventional open hole logs, and some special open hole logs if we have this data. And as I have mentioned before, it is really important to calibrate the petrophysical property measures by well logs with core data. So this is the basis for estimate the hydrocarbon volume in place. And we need to know the original pressure of a reservoir. We can use the wireline formation tester, for example, for estimate the pressure. And we can also sample the fluids in the same zones of the reservoir. We need to understand more about the fluids that it contains. So these two tables represent the first part of the study. And when you start the production of a field, we use some cased hole logs that will support you in many decisions. So we have posted neutron or saturation logs that can show you and let you know to understand the distribution of the fluids in the reservoir. Production logging tools that can help you understand what are the most productive zones, what kind of fluid the determined zone is producing, and among other things. CBL, VDL, that are cement bond log, variable density log, that are tools that can use it to evaluate the cementation of well and case inspection that we can use to evaluate what is happening with case in time, because we can have some problems with corrosion, leak, hole, that I will explain in a few slides. So now I will show you some applications for matter fields related to the petrophysics. This is a workflow, thinking just in this kind of fields. The first thing, in my opinion, that we should do is refining static and dynamic model. When you receive data from a matter field that, for example, your company bought from another operator, we should do this type of reservoir studies. So in my opinion, it is necessary to perform rock typing and saturation height modeling, because it is important inputs for dynamic model and static model, and it is the first thing that we should do. And we can work with these production logs after you have this test done, and there are no priority in which one will you run before. It depends of what is occurring in your field, in your reservoir. But we are talking about case hole logs, reservoir monitoring with pulsed neutron, producibility that we can use, production logging tools, cement evaluation, and casing inspection. So continuing this workflow, the first application is to perform a rock typing and saturation height modeling. So the first thing that we should do is the volumetric interpretation. We should have a very good value calibrated with core of porosity and water saturation, because they are the inputs for hydrocarbon, volume of hydrocarbon in place. And we need to integrate with the core that to have the best match. And this is one of the inputs for the static model. Another input is the phases. The phases come from the geologist, and the geologist can provide us information about lithology, the positional environment, and we can use that to populate this information in well logs. So we can use some techniques of machine learning to populate for example, a static model with information from logs. The second step is to do something that we know we can call as hydraulic flow units or rock types. These are very important for production because it is a kind of petrophysical rock typing, and we can understand the behavior of some zones related to the production. So with this approach, we use permeability and porosity. There is one way mathematical equation that can be used to estimate these hydraulic flow units. After that, after you have a reservoir divided into many types of hydraulic flow units, you can develop a saturation height modeling. Saturation height modeling correlates permeability and porosity with the height of the oil or gas or contact. You can apply one equation, and you can have better estimates of water saturation. This is very important information for dynamic model, because the saturation height functions are a primary input in modeling the fluid distribution in the reservoir simulations. And again, we need to do this hydraulic flow units prediction using some techniques from machine learning. In this case, self-organizing maps or cluster analysis. There are another types, for example, neural networks. But in this example, there are these two types that can be used. So, and how can I perform these studies for hydraulic flow units? I will start talking about core domain. You can see here some cross plots. This is the rock quality index against normalized porosity. This information comes from core. And what we can see here is that we can divide our reservoir in 6 hydraulic flow units that have the same behavior related to port road height, to the same properties for the same permeability, porosity estimations. So this is the first thing that we should